Hey guys, so today we're going to be looking at a really interesting um, anti-analysis technique. I say interesting all the time, so I'm going to try and remove that from my vocabulary. But essentially, I've talked about a load of different anti-debugger methods a number of times. There being an actual dedicated video, anti-analysis, which was mostly looking at API calls, is debugger present, etc. Um, and then I also talked about some anti-debugger methods to do with the PEB when I was looking at the smoke loader and how I was dissecting that and the video series that I did there. So that was quite a large video, but inside that I did talk about how, there is the debugger present flag in there and how that would be interesting for a malware creator. With this one, I have seen this recently. I think it's a pretty cool method that I hadn't really thought of and looked at really, and so it actually sort of spurred me into making a really cool video. Um, so I sort of stole part of the code, most of the code, every bit of the code from this URL, antidebugcheckpoint.com. Really cool resource, really nice to see. And what I did for the video is I just simplified it a little bit and repurposed the code to make it a little bit more simpler for people to understand and go through step by step, rather than their simple Boolean sort of function that made it a little bit more complex to really understand what was going on. And then I also looked at some additional stuff with memory allocations and sort of the peculiarities with when something's debugged, what's going on with memory allocation and different types of stuff related to that, which I thought was really cool. So definitely, if you're interested in this type of stuff, you should look at those two URLs for sure, and also do your own research. I think the coolest thing is watching sort of threat actors do something and then sort of work it out and then go from there, look at it and be like, wow, is anyone else seeing this? And of course they are, and you learn something new in a day and it really spurs you on. So yeah, the C code is pretty simple. We're creating a heap of 100, allocating of 100, and then we're going beyond that heap size and determining what is going on there. And apparently it should be ABAB is the environmental determination. And then we're just doing a casual heap free. I don't know why I say casual. Then we're doing just what we should be doing afterwards. But there is this determinism where either it's not or it is. And I did a rerun of this. Well, this is the rerun, so you've just got to excuse my mind at this point. Like, of course, that doesn't make sense, but I'm not going to recompile it now. I'm smooth sailing. I know what I'm doing. But yeah, so there's two different options here. So that's what we're going to be looking at, this ABAB. Now, when we previously talked in the smoke loader video about the PEB, what was really interesting is how you could obfuscate that and change that. And that's actually something also that we could talk about here is malware developers, at some point they have to have a conditional where they check this to determine whether there is a debugger or not. But outside of this value can be manipulated until the final step, which is what a lot of them probably would do and do. So something to take into account is this: heap free, heap destroy, HeapAlloc, heap create. All of these things are commonly observed in software and malware. So it's not particularly easy to identify it off the cuff until you sort of determine what is truly going on in other areas. So yeah, that's particularly interesting. So let's get into the VM and start looking at the the compiled bin from the debugger and IDA level. Okay, so if you're relatively confused by the constructs that you can see, I don't know if construct's not the right word, the declarations. We're using MinGW with GCC. Yeah, I'm just comfortable with that environment. People might get upset about that. I'm afraid. I'm sorry. That's how I work. So yeah, one of the first things is to create a heap, and then we need to allocate it, and then from there we start to see the changes in the add, which we can see here, which 101. So adding it on from then and determining whether we saw it in the source code, but this step by step, once we do this in the debugger, be a little bit easier. I wanted to see the IDA output for my own interest and probably also to show you as well what it looked like, because the best thing is to sort of create your own code and sort of work from there and see it in disassembled format and also debugger format to work out what's going on. This is pretty simple. The dwarf information was included, so you know sometimes that does happen in malware, but not huge amounts. So yeah, but pretty easy, I'd say, now that you can see the source code, what's going on. I always find it interesting seeing puts. Yeah, always interesting to see that. But yeah, let's just go straight into the debugger. I have breakpointed. I didn't go through. So of course, idle obviously determines straight away where we are, where the user code is compared to the compiler code. But what I'm going to do is I've actually sort of half cheated and I've set a breakpoint right at the start here, create an example heap, just because hopefully it works. There we go. Fantastic. So we've got our little lovely thing here, command line, that allows us to see what's going on. What I'm going to do as well is I'm going to show it outside of a debugger context. So going into downloads, let's run it. So that's what happens when it's outside of a debugger. We see create an example heap, it checks, and it's not in the heap. The English is not great from me there. I'm not helping myself, but that is that's outside of the debugger. So let's see it inside the debugger. And again, this is a bit like with the PEB, there is a flag that you can set to change the way that this is determined. As always, the mechanisms for making this, if you had malware that did this multiple times, it would be quite annoying. A little bit fiddly, this sort of technique to try and alter. Not terribly, because you've got the condition you can knock out. I think there is a flag as well that you can alter from my memory. But yeah, let's go crack into it. So first we're going to create a heap. So we've got 78. So let's go into main and let's go into 78. As we can see, this is what the heap looks like. Lovely stuff. Nothing too out of the ordinary. We can see that. Great. Lovely stuff. Now what we're going to do is, of course, we're setting up the arguments for the allocate heap, so we can see the 64 again, the 100. So allocate heap, we see it's 7804B0. So what I'm going to do is I'm going to refresh, and then wrong one. There we go. What I'm going to do is I'm going to save this as dump.bin. Oh, lovely. Now, many of you might be confused by what's going on here. But this is to do with heaps. I haven't done too much research into this, but there's heap guards and different identifiers for it. This isn't, when I first looked at this, it isn't like malloc and virtual alloc, where you just clear memory or, you know, have very static values. There's a lot added into heaps as well, which I wasn't ready for when I first did this. So that was quite fun. Yeah. So what I'm going to do is I'm going to go to HXD. And I'm going to get the dump open, if I can remember where that is. Give me a second. Cool, so we've got the dump open. Just for people that are unsure, that's 81CE, that's 81CE, we're in the same place. So we've dumped the memory, and if we go to where the debugger said, so 04B0, we don't want, of course, the 78 because we've dumped it, the 04B0. So let's get to 4B0 there. And that sort of makes sense because we've got this strange stuff here that isn't to do with anything that we've set. And then we've got some blanks here, which is good. And if I just stop it there, we can see that the length is 64, which is 100, 64 in hex. And then we've got this trailer here, which is ABAB. Now, the interesting thing about this technique is when you allocate a heap with the debugger in, whether that be in Visual Studio or here, it will have this or these values set in the memory, which is interesting because if you allocate a heap and then say I want to go one beyond and set a D word and read whatever's in that D word, you get the values ABAB, which is to be expected, which means when we set, as it is here, right, 65, 101, what it's like in the source code, if we set that, and if I take the step, so we're adding, so now we're in that region, we've gone to 100, and now we need to set it as a D word, which means coming back. And we'll see EAX at this point become AB and AB, hopefully, if I'm correct. Yep. So then from there, the EAX D word goes into wherever our variable is, which at this point is EBP minus 18. And then from here, we're going to print whether we're checking. And here you can see the comparison straight up where we're checking if our variable that we've set also here equals ABAB, which it should because we're in a debugger. And jump if not equals. So let's give it a go. And it not equals. And so then we've got the puts. And it is on heap. So then it prints out. And that's simply it. That's the coolness of it. Is that there's these values right at the end of heap allocations, which make it really nice to sort of work out whether you're in a bug after the HeapAlloc, which I think was worthy of a little quick video to show you guys something I've been doing. So yeah, hopefully you enjoyed, and I'll see you guys next time.